Which one? Yep. All right, so we got 10. Now, if I'm looking at y, okay, that's the angle that is going to dictate the labeling of the sides, right? So 3n would be opposite, 4n would be adjacent, 5n would be hypotenuse, correct? Okay. Now, if I want to find y, I'm trying to find an angle, we use the inverse functions, okay? In this one, if I looked at sine inverse of y, it'd be 3n over what? Careful. Because sine is opposite over hypotenuse, so we go 3n over 5n, okay? And n is just a multiple, okay? N is it could be anything you want it to be, but it's consistent in all of these. So what is n divided by n essentially going to give me? 1. So I really just have sine inverse of y equals 3/5. Or I can look at cosine inverse of y. And what is cosine? What sides? Nope. Nope.
C equals A over H.
A over H. Okay. So 4n over 5n. Okay. N's again are a factor of 1. And then I can do tangent, which is opposite over adjacent. Okay, so 3n over 4n. What happens to my n's? They cancel out. Okay. The idea here, guys, I don't know if I still have the picture up here. I don't. The idea with the n's is n could be anything. So let's say n is just 2. Does that make that 8, that 6, and that 10? And then if I do sine with those values, it'd be 6 over 10, right? Opposite over hypotenuse. Well, what's 6 over 10 reduced to? 3 over 5. Okay? If n was 3, I'd have 12 and 15, or sorry, 12 and 9. Okay, and this would be, what, 15? What's 9 divided by 15 now? What's that reduced to?
3 over 5.
3 over 5 again, okay? So this is actually 4n, 3, and 5n are giving you the infinite number of right triangles that are in the Pythagorean triple format of 3, 4, 5, okay? But they're all going to have this angle right here that is defined by these values. So when I evaluate those, let's see here. Sine inverse, what do we have? 3, was it 3/5? Gives me that angle there. We had cosine inverse, which could have been, was it 4/5? Is that the same number? So show you could use either one of them. And then tangent inverse is 3/4. And it gives me the same number again. So you see, because we have all 3 segment lengths, you can use any one of these inverse relationships to find that angle. Is that doable? Okay. Because even if I don't know if Desmos will do this. Okay, so let's see here. What it's doing right now, and you're not seeing anything happen, but as I change this n value, up top right now, I have really 9, and on the bottom I have 15, right? So 9 divided by 15 run through the sine inverse is still that number. So you see as I change that n, the only time it changes is when n is 0, because now you have division by 0, which is a problem, right? So we can keep, yeah, okay. Now, because the negative divided, so there I would have negative 21 over negative 35.
Yeah, negative 5, negative.
Exactly, okay. So we're seeing that n could be anything that it wants to be, and I still get that quotient. So 36.86 is, it's a degree, and that's what we're looking for y. Any others on the front? Eight. Okay, so this is another example of that. Now this doesn't use in, so that maybe confusion is out of the picture. But if that's the angle we're looking for, this would be opposite y, this would be adjacent, and this would be hypotenuse, right? And because we're looking for an angle, we know we're either using sine inverse, cosine inverse, or tangent inverse. We got to use one of those. Well, if I'm going to use sine, I need to know the opposite side and the hypotenuse. Do I know those? Yeah. So 8 over 17. But I also know the adjacent and the hypotenuse, so 15 over 17. But I also know opposite and adjacent, so I could say 8 over 15. Because you guys know all three sides. And this is something to think about. When you're looking for an angle and they give you all three sides of your triangle, then it's fair game on which ratio you want to use, okay? You can use any one of them. Now, if they don't, let's say we look at, question 11. I don't know all three sides, right? I only know the opposite and the hypotenuse here, correct? So which trig ratio do I have to use? What uses opposite and hypotenuse? Guys, this is not hard. Remember that. SOHCAHTOA. Opposite, hypotenuse. Okay? 3. So sine inverse uses the opposite side, which is 3. Hypotenuse, root 34. Does that kind of make sense? And there I can't use cosine or tangent because I don't have the adjacent side, which would be this side here. So those are out of the equation. All right.
How you know how to use like sin?
Yeah. Sine.
We have to do something.
Okay. Do we need to do any of these on the bottom?
Really, Chuck?
Let's do 16 because 16 we can do both. What kind of triangle is this? Right triangle. But it's a 45, 45, 90, right? So isn't this side going to be, if this is in, that's got to be in, doesn't it? So it's got to be 82. Now here's something that's fine if you saw that, but if you didn't see that, let's take that 45. Can I say the tangent of 45 is equal to W over 82?
Yes.
Okay. Well, multiply both sides by 82. I get 82 tangent of 45. Type that into my calculator. If I type in 82 tangent of 45, give me 82 back. What's that tell you tangent of 45 is equivalent to?
8.
If I'm multiplying 82,
1.
yeah, it's got to be 1. Tangent 45 is 1. If I'm multiplying 82.
Remember stuff like that?
Huh?
Do we remember stuff like
I mean, it's helpful. Is it necessary in this class? No. We get the trigonometry, yes. Okay. So that now gets me into this triangle over here, correct? Now, this is not a special right triangle, so here I have to use SOHCAHTOA. Okay, W, looking at the 28, W is the opposite side, right?
Yeah.
What's Z?
Z is the adjacent.
Adjacent. Which ratio uses opposite and adjacent?
O over A would be, yeah.
So, tangent. Somebody used, is that what you say, T? Okay.
T equals O over A.
Yep. So tangent of 28 is equal to 82 over Z, right? Now, we can go through the algebra here, but what did we talk about yesterday? That thing and that thing, if that's a variable, what are they going to do with one another? or in relationship to one another through the algebra.
No, that has to be you're gonna multiply.
You're going to multiply both sides by z, and then you're going to divide both sides by tangent 28, right? And that effectively just gets those two things to swap spots. So I'll get z on the left-hand side, 82 over tangent 28 on the right-hand side. And I'll leave that to type for you to type in, but that'll give you that measurement of z. Is that okay? A little bit.
I think the test on Thursday is still you know, Brandon. I don't know if you don't know.
Ask me Thursday.
I'll get on Thursday.
Oh, you want to take it Thursday? Ask me tomorrow. All right, so this one here, we're going to find z and w, okay? Now, z is just that portion there, right? Which is just a part of this triangle here. I cannot use SOHCAHTOA in that triangle because it's not a right triangle. Does that make sense, everybody? All right, but so let's just focus right now on w. What kind of triangle is this here in w?
Right.
Yeah. So this is my n radical 3 side, right? It's going to divide by radical 3, divide by radical 3. So that's going to give me n to be that, okay? I will rationalize that by multiplying by radical 3 over radical 3, so that gives me 900 radical 3 over 3. What's 900 divided by 3?
300.
300, okay? So that gives me my n value, which is across from your 30 degrees, right? So w right now is 300 radical 3, if you went that route. Okay. Now, some of you might not go that route. Some of you might say, I don't like it. I'm going to look at this 60 degrees, and I'm going to say this is opposite, and W is adjacent. So I'm going to say the tangent of 60 degrees is equal to 900 over W, right? You're going to flip-flop these two things. You get W is equal to 900 divided by tangent of 60. Those two numbers are what? What's the relationship between them?
What does S equal again? S opposite over adjacent? Yes. No, that's T.
Opposite over hypotenuse.
Oh, opposite.
If I take 300, square root of 3, gives me that value right there, right? Okay. I'm going to take 900 divided by tangent of 60. Give me the same number. So could you use either SOHCAHTOA or could you use special right triangles
Yes.
to find W? Yes. Now, if they say, leave your answer in simplest radical form, can you use this?
Yes. No.
No, you would have to use that approach, right? Okay. Whenever they tell you, leave your answer in simplest radical form, they're providing the fact that you're probably going to want to use the Pythagorean theorem or special right triangles, which are really the same thing. Okay. Now I got to find z. Well, I can't find z until I find
The length right there.
that entire distance, right?
Well, you know that.
No.
Z minus W.
That'd be z plus w, right?
Oh, you want the tires.
So
Yeah.
x, if I call x, that is equal to z plus w, right? X equals z plus w. Well, I want to solve for z. So z is
You only know the.
z is x minus w, right?
Yeah.
So let's find x.
Well, you only know the adjacent.
If this is 42, and this is 900, right?
Yeah.
And this here is my x.
Yeah.
Can I say tangent of 42
Opposite over A.
is 900 over x? So x is 900 divided by tangent of 42. Does that make sense?
Yeah.
Okay. So that's x. We already know w, right? So can I say 900 divided by tangent of 42 minus w, and whatever version of w you want to use. Maybe I use 900 tangent of 60. If I type that in, just like that, it will give me the distance for z. Which is nice because that is now a component of a non-right triangle with that 42-degree angle in there. which is going to kind of maybe lead us into one of the later sections in this chapter. All right, so now let's. I know, time is shortened today, but if you're struggling with these things, it'd be a good idea to go back through the video, go back through the explanations, see if they make sense to us again. One of the questions I give to you here is question 20, and I did this on purpose because I'm sure a lot of us probably didn't know what this meant, right? Okay. What is the grade of a road? Anybody know what that means? Not the angle. This is the angle. Okay. So it sounds like we didn't know, right? What do you always have at your fingertips? Fingernails. You got Google, right? You have the ability to type in grade of a road. And when I type that in, it says road incline grades are given in percentage, which is the rise over run percentage. What's rise over run?
Slope.
Slope. So when they say the grade of a road, they mean the slope. Okay? All right, so when they say the horizontal is anything, it's like the horizon, correct? Okay? So the way I view this, the way I'm thinking about this, let's say this is a road, and let's say this is like I-75, and you're traveling down I-75, right? And you're going to come up to the Slabtown the Slabtown overpass, and you look at that, and it starts to do that, right? To get over that road. They're saying that that road that is going over the overpass, that is creating the overpass, is rising at an 8-degree angle. Does that make sense?
Yes.
We want to find what the grade then is referred to as. So if this continues to rise, don't I end up with a right triangle here?
Yeah.
Okay. Now, the slope of this road, any little section, so let's start there and go to there. The slope of that line right there, the slope of that portion of the road, should be exactly the same as that portion, as the blue portion. Does that make sense? Which would be exactly the same as the entire road. And that's something you should know from Algebra 1. If I graph a line in Algebra 1, let's say that I go y equals 2x plus 3. If I graph that line, I'm in 3D. Let's see here. If I graph y equals 2x plus 3, okay? If I just look at that section of the line, what's the slope of that section of the line? It's the same as there, right? It's the same as there. It's constant. That's a definition that we've talked about, we talked about for lines. So why do we need to talk about that? Is because they don't give me any other values in this problem, right? So the argument then is, if I look at this little red triangle and I find the rise over run of that, it should be the same as the rise over run of that blue triangle, right? Which should be the rise over run of the entire road, or the biggest triangle. So what they're saying is you can arbitrarily choose whatever you want your horizontal distance to be. Okay, let's let that be, 3. 3 feet, 3 miles, 3 whatevers. Okay? Now, if that's 3, I don't know what this is. Okay? Because that is that vertical distance is then made by this 8 degrees. Does that make sense? Okay? So I'm going to call this y. Would you guys say that tangent of 8 is equal to y over 3? And then 3 tangent of 8 is equal to y? Does that make sense, everybody? And that will give me that vertical distance. So, let's see what that is. 3 tangent of 8 gives me that number right there. Okay? So if this is 3 feet, 3 miles, 3 meters, whatever, this is 0.42 feet, 0.42 meters, 0.42 miles, whatever. Does that make sense?
Yeah.
Well, the rise over run then, this is the rise, this is the run. Can I take that number and divide it by my run?
Yes.
It gives me that 1.1405, right?
Yes.
That's my slope. They said the slope is presented as a grade. It's a percentage. So let's change that to 14%. Does that make sense? Now I chose 3. What if I chose 5? Well, if I chose 5, the only thing that changed, so that denominator becomes 5 here, right?
Yeah.
This number out front becomes 5, right? This here obviously would have been a 5. So can I take 5 tangent of 8? Changes that number, right?
Yeah.
But now what is my denominator down here?
5.
Yeah, it's 5. So I'm going to take that number. That's my rise. I'll divide it by my run. Do I still get the same 0.14 number?
Yeah.
Okay? And you can do that with any value you chose. Okay? And the same thing happens, guys, if I would have said, well, I'm gonna dictate my vertical rise to be maybe 4. And I don't know that distance, x. Okay? We could do rise over run that way. But that's what they mean by grade of road. Now, the reason I give you that question is because, one, I hope that you have the instincts, you have the ability to say, I don't know what that means, so I'm going to dig a little bit. Now, I'm not saying spend 3-4 hours trying to figure out what grade of a road is. I'm not saying sign up for a civil engineering course. I'm saying get on Google and type in what is the grade of a road, and that can help you, okay? But this is a lot of people that write standardized tests, ACT, end of course exam, are going to think that there are things that you know as common knowledge. And grade of a road is one that a lot of times they say is just common knowledge. People should know.
Is that like a?
I don't think it's something people should know, okay? But now you should know. And if you see that, it's something you should be able to do. All right, so the other questions. The back was hard because we collectively, not saying this for everybody, but overall, we struggle retaining information from previous chapters. Question, was it 20? This Rhombus question? 22? What do you know about the diagonals of a rhombus? Nope.
They're perpendicular.
They are perpendicular. Okay. So you get a bunch of right triangles, don't you?
4, actually.
What else do they do? What do the diagonals of any parallelogram do to one another?
Intersect.
They do intersect, but how?
Perpendicularly.
Okay, not all. Just for rhombuses, we've already talked about that.
Bisect.
They bisect. So they cut each other in half, right?
Yeah, they.
So if this blue one was 4, what is it cut in half?
2.
2. And the green one was 10?
5.
5. Now they ask you for the angles of the rhombus, right? But with that little triangle, don't you have the ability now to find that? Does that make sense to everybody? I'm going to pull that little triangle out. Okay, I'm going to call that angle A. This is 5. This is 2. Can I say that tangent of A is equal to 2/5? So then tangent inverse is of 2/5 should equal angle A. That makes sense to everybody? Okay. Now, if tangent inverse is equal to, tangent inverse of 2/5 is equal to A, how can I find that red angle once I find that number? If I take tangent inverse of 2/5, gives me that angle right there, right? That is just this black angle. How do I get the red one? I double it. So there's the red one, okay? So that's one angle of my rhombus. How do I get the other angle of my rhombus? How do I get that one? Nope. How does the red one and the blue one relate to one another?
They're parallelograms. So then it's the same length. It should be the same length. The same angle measurement. Degrees, yeah. Oh, they're supplementary.
They're supplementary, okay? There are those two angles in parallel lines, right?
Yes.
So if they're supplementary, I need to take 180 minus that thing, and that will give me that blue angle down to the bottom. Okay? Do you see how previous information is going to come back to haunt us if we're not going to let it sit in, okay, or settle in, and we mess with it and continue to work with that old information. Otherwise, we're going to struggle mightily in this last 9 weeks, okay, because these are going to come back and be used a lot. Real quick, I know time's going to run out here on us, and we'll talk a little bit about some of these tomorrow. With these figures here that were in like 27, 28, do you see that red triangle that we're trying to talk about there on the inside? Not that triangle. We're talking about that one there. Is that okay with everybody? Okay. Now, in the first one, they tell you that this is a height of 2. They tell you that this is 3. Okay. And they tell you that this is 4. So what you need to do is you need to find this bottom dotted line of that triangle. Okay? Well, if I look at that triangle right there, looking straight down, if this is 3 and this is 4, what does that got to be? Or what does that hypotenuse got to be?
4 squared.
Good. It's got to be 5. Okay? So, if it's 5, do you now know, looking at that maroon triangle, look at the maroon triangle, this is 5. Okay, this would be D, and that would be H. So it's that side right there. That's 2. That angle right there is what they're asking for, which would mimic that angle right there on that maroon triangle on the interior. Can you find that?
Yes.
Using what's trig ratio? If you have 2 and 5. Tangent. You use tangent inverse of 2/5, should give you that 21.8 degrees. Okay. The next question changes things. It's no longer 3, 4, 5. They use the word cube. What's a cube?
Small thing.
What is a cube?
Cube?
A
It's like
cube.
It's a 3D shape. Cube?
It's a 3D shape. It's a prism.
Yeah, I think it's like a cube. Cube, baby.
But what is unique about it?
It's all side lengths. Side lengths. All sides similar.
Okay, there's a cube right there, right? Okay. All the sides are the actually that's not a cube yet. That's a cube. Maybe not. Well, I can't. I apologize.
We just pretend. Right there.
Okay, so there's a cube. They're all side lengths of 3.
Yeah.
Okay. Now they don't give me a side length of 3, do they?
It's not beyond the.
So I use 3. You could use 4. You could use 10. You could use 12. You could use X. Okay? It does not matter. The only thing, the reason they give you cube is that the relationships all have to be the same. Because then, using the same approach to the last question, if that's X, this little distance here is X, and that distance there is X, right? Looking straight down on this thing, what kind of triangle is that red triangle? It's a right triangle, but if both sides are the same, it's a isosceles. And what's another name for an isosceles right triangle?
45, 45, 90.
45, 45, 90. So if that's X, that's X, that's X. Radical 2, right? So now looking at that maroon triangle, you now know in that maroon triangle that the distance, I don't know why that one erased, the distance here is X radical 2. This vertical distance is X, right? Can you find that angle right there using tangent inverse of the opposite side divided by the hypotenuse? What's going to happen with those X's? They cancel out. So I'm left with 1 over radical 2, right? Now think about this. If you chose side lengths of 3, what would that would replace the X's with 3. What would they cancel? Or would they cancel out? Yes. What if you chose 12? Yeah, they cancel out again, right? Every single time, no matter how big your cube is, your side lengths are going to cancel out like that, leaving you 1 over that. On that, I want you guys to finish that back page. Finish the back.
Oh.